Hi everyone and welcome to the Learning Curve. In this video, I will be doing an illustrative lesson providing a worked, typical final exam paper that is done in mathematics for business and social sciences in universities at level 1, year 1. Here we are told in our first question that the amount of dollars that results from an investment after T years is given by this exponential growth function. We know this is an exponential growth function because the coefficient of the exponent is a positive figure here, 0.2. If it was a negative figure, it would be an exponential decay function. We are asked in the first scenario here to find what is the initial sum that was invested. The initial sum or initial value in an exponential function is always going to be where the variable in the exponent, in this case t, is equal to 0. So basically we're going to find the value of a when t is equal to 0, and this will be 5,000. A equals 5,000 e raised to the power of 0.12 multiplied by 0, because the initial value, as I indicated, will be where t is equal to 0. So this works out to be 5,000 e raised to the 0 power, because 0.1 multiplied by 2 will be 0, multiplied by 0 will be 0, any number multiplied by 0 is 0. And then we simplify this as 5,000, and any number raised to the power of 0 is going to be 1. So I put 1 in bracket here. So 5,000 multiplied by e to the 0, which is 1, will give us 5,000. So it means that the initial value invested was 5,000. Let's now move to number 2, which is a similar question that asks, what will be the amount after 5 years? So in other words, when t is equal to 5, remember t represents the number of years, so when t is equal to 5, what will be the value of a? So all we do is to substitute 5 here for t in the exponential growth function and simplify. So this would give us 5,000 e raised to the power of 0.12, and we're multiplying by 5, which is the number of years after which we want to find the value of the investment. So this would be equal to 5,000, and we're going to raise e to the power of, when we multiply, we're going to multiply 0.2 here by 5, and when we multiply 0.12 rather by 5, we get 0.6. Then on our calculators, we can raise e to the 0.6 power and then multiply that answer by 5,000, and we will get 9,110.59. 9,110.59. So the value of the investment after 5 years will be 9,110.59. Next, we're asked how many years to the nearest year will the initial investment take to triple in value? So in this case, we're asked to find the value of t, because we're asked to find after how many years will the initial investment triple in value. The initial investment was $5,000, so when it triples in value, it will become $15,000. So let's write out our function here again, or the function, the exponential growth function that we were given, which is a equal 5,000 raised to the 0.12 t. So we're going to replace a here with 15,000, because that will be the value of the investment when it triples in value. So 15,000 is going to be equal to 5,000 e to the 0.12 t, and in this case we are interested in finding the value of t. So we're going to simplify this equation, and to simplify this equation, I first try to get rid of the term that is multiplied by the exponential, which is 5,000. And to get rid of that exponential, I will divide both sides, both sides by that coefficient. Rather, to get rid of this coefficient for the exponential, that is the term multiplied by the exponential, we will divide both sides of the equation by that coefficient of 5,000. You know, what you do to one side of an equation, you have to do to the other side to maintain balance. So dividing the right-hand side of the equation here by 5,000 will eliminate the 5,000 that is multiplied by it, but we have to also divide the other side by 5,000 to maintain balance. So when we divide 15,000 by 5,000 on the left-hand side of the equation, we get 3. And here when we divide 5,000 by 5,000, we get 1. So we're left with e to the 0 raised to the power of 0.12t. Now our task is to try to get the power which contains the unknown down. So what we need to do is to try to get t and this entire power to be in a more workable form and a more solvable form. So to get this power of 0.12 to come down to be a coefficient, what we're going to do is that we're going to take the natural log ln of both sides of the equation. So we're going to take ln3 equal ln e to the 0.12t. So what we're doing is that we're taking the natural log. The reason for taking the natural log here is that when you take the natural log of a term with a power, the power comes down to the front of the expression, making it easier to solve. So this is the utility of the natural log here. So in order to get the power here, which contains the unknown that we're solving for, to become a coefficient, so that the equation becomes easier to solve, we take ln, which is the natural log of e to the 0.12t. Since I'm taking ln of the right-hand side of the equation in order to achieve the objective that I just stated, then I have to also take ln of the other side of the equation. So here we will get, when we take ln, so this will remain ln3. ln3 is going to be equal to, when I take ln of this power term, the power comes down to the front of the expression. So 0.12t comes down to the front. So I'll have 0.12t ln e. Then we'll simplify this further. ln3 would be equal to, now ln e by definition is equal to 1. ln of the natural log of the natural exponential is equal to 1. So here we're going to get 0.12t multiplied by 1, which is just going to give us 0.12t. Because any quantity multiplied by 1 based on the identity property will give us back that same quantity. So we'll just be left with 0.12t here. And now easily to get t, we're going to divide both sides of the equation by the coefficient of 0.12. So ln3 is going to be equal to 0.12t divided by 0.12. In other words, in order to get rid of this coefficient, this term that is multiplied by t, in other words, which is 0.12, I have to do the inverse of multiplication, which is to divide by that same number, 0.12. And what I do to one side of the equation, I have to do to the other side. So I divide the left-hand side by 0.12 as well. 0.12 cancels on this side because it divides into itself once, leaving us with t equals ln3, which we can evaluate on our calculators, divided by 0.12. So on our calculators, when we take ln3, natural log of 3, divided by 0.12, we get t equals 9 years. So our answer here is t equal 9 years. That is, after 9 years, it will take 9 years for the initial investment of 5,000 to triple in value. So this is something that is extremely practical and useful in ordinary business life, especially in areas like finance and population growth forecasting, investment forecasting, forecasting the value of the future value of investments, extremely useful in those fields.